is where the camera. Yeah. Okay. Okay.
Is the Zoom session going? Okay, let me welcome everyone again to our Wednesdays at NICO seminar. I'm super excited about today's speaker because she was a PhD student here with me years ago. And she's done amazing stuff since then. But she's also worked with other people at Northwestern, and actually I'm gonna let Haejin Yoon introduce her, just to clarify, because her name spelling can be confusing for people, pronounced Haejin. A lot of people get confused. But Haejin is a professor in the Kellogg School here. And I think I didn't get a chance to check. By courtesy, also, are you also in civil and environmental engineering? And also a key member of NICO. And she does amazing work also on complex systems and socio-technical systems. So, but it's not an intro for her today. So let me just pass the mic to her and let her introduce Vicky as her collaborator.
Okay, all right. Thank you very much. Thank you. And welcome back, everyone. Wednesday at NICO. And it's my great pleasure to introduce and welcome Vicky Yang here visiting us. Vicky is a assistant professor at MIT Sloan System Dynamic Group. Her academic journey began with the physics undergraduate at WPI, and then came to us, becoming purple, PhD in applied math with Danny, and very good. That I think that was the time that I met her for the first time, and we spoke about Santa Fe Institute, and she had various options in the outside of academia. I remember the fantastic options in industry, and I'm glad that she stayed in academia. And eventually she became a postdoc at Santa Fe Institute, where she did a really great work about how the cities, how the urban properties scale with the city size, and also working on the voting dynamics, and also how different kind of organization diversify and specialize. We're working together, and that was the time also that we since then I had a great privilege of working with her, and we actually had her co-PI had a multi-million-dollar at NSF grant. At her career, that is like a huge success, phenomenal success. So today, she's going to talk about the collective intelligence and the collective decision-making and voting system in the lens of the dynamical systems models. And I'm so it's always inspiring to welcome back to this proud couple, our one from our community, especially one who's out there and making wave and coming back. And please join me welcoming our own alumni.
Hey. Thank you. Thank you for the kind introduction, Haejin and Danny. It's such a pleasure to be back. I've been in the audience of this room for many, many times, so it's great to be on the other side for once. So in today's talk, I would like to give you an overview of two research projects. The first of which looks at the phenomenon of political party polarization in the United States, and asking how do we end up with polarized parties while the electorate as a whole hasn't changed as much as people would expect. And then the second project zooms out to look at collective decision-making in general, sort of abstracting from voting and in the political election context, and ask how can we make good collective decisions when some people just don't care about the facts and they learn from following others. And both projects are inherently multidisciplinary efforts. So in the project, we worked with Danny and Adilson at Northwestern, and we also involved political scientists, psychologists, and economists in these endeavors. So without further ado, let's talk about party polarization first. So let's start by looking at some data. There has been ample evidence that the US Congress has been more divided than before. So this is a co-voting network of the House of Representatives in the 1950s. So blues are Democrats, reds are Republicans, and the ties are how often they voted together on the same side of a bill. And that is a picture in the 2010s. So we can see that there is a lot less across the aisle co-voting between the two parties. And the natural question to ask is the picture we see in Congress a reflection of a more polarized public? And that is actually a lot more complicated than we thought. So in the media, we hear all the time to say America is more polarized than before, but there is a subtle confusion of two types of polarization. So the first type is called sorting. That is, how much do policy positions reflect people's party label? That is, given that you are a Democrat, how likely you are to support liberal policies and vice versa if you're a Republican. And we have seen that the policy position support is sort of sorted into party labels. So it used to be we have somewhat liberal Republicans and somewhat conservative Democrats, and now we see that a lot less. So this has been happening, but then there's some literature that have argued is less than what's happening in Congress. The second measure is called divergence, which is asking if I'm blind of people's party labels, do we actually see people become more extremist in the view they take? So do we go from a one-humped distribution where most people are in the middle to a two-humped one where people are spreading out to be in the extremes? And there isn't a strong evidence of this is happening. Another look at this kind of phenomenon is taken from this political science paper where they measured ideological divergence within the public and also within the senators. And they have found that it's steady among the public, but has been going up steadily in the Congress. Okay. So the key questions we want to ask here is what mechanism can generate polarized parties without the public actually taking more extremist views? Okay, so before I talk about how we might come up with a mathematical model for this phenomenon, let me first tell you about how one can quantify party positions. So one can use the data from congressional roll call records, which is how each congressional member voted on either side of a bill, to vote yes or no. And there is an algorithm developed in the political science community called the DW nominate method, short for dynamic weighted nominal triple step estimation, which is a mouthful. But what it does is the following, that for every pair of congressional members, it computes a distant relationship between the two. So those who vote similarly will be closer together, and those who vote differently will be further apart. So for example, between Sanders, Biden, and Cruz, we may have a distance relation like this. And after having this high dimensional network of all congressional members, it tries to project it down into a low dimension while preserving the pairwise distant relationship as much as possible. So if I were to put these three people on a line, I'll probably put Biden somewhere in between Sanders and Cruz. And after we do that, for every congressional member, we can get a histogram of this ideological position that's collapsed down. This is an example for 2015 where the blues are the Democrats and then the reds are Republicans. After doing this for every year that we have history for, we can basically have this time history of evolution of the two parties, where the data starts in the 1860s, where the two-party landscape in America just formed. And these solid lines are the mean of the distributions, and the shaded region are one standard deviation. So we can see that from the end of Second World War to now, there's a tendency for these two parties to drift apart. However, we've seen, sort of according to this measure, some similar metrics of polarization back in the past. Any questions so far about this? Yeah. external, whether the external politics affect this behavior. So here the metric, the position is a relative metric inherently, that this metric doesn't know, like taking like a value of 0.5 reflects what kind of policy stance. So in that sense, it's hard to make that concrete. But I would imagine the bills may also reflect some reactions to external environment, especially in the war periods. Yeah.
So my question is that possible to think of the two-dimensional or three-dimensional ideology position?
Yeah, so in the data, the folks who worked on this method, they have a two-dimensional version of this landscape, and there's some more, it's hard to interpret what each axis is. So I think there's some ad hoc explanation of what these two axes are, but I think that's up for a lot of debate. I use the one dimension because I think in Congress, at least, one dimension explains, I think, the vast majority of voting patterns, at least now. So I think it's like over 90% or something. So we stick with that. But it's possible to do higher. Okay, moving on. So this is the data. And there has been a lot of effort in trying to model where parties sit in an ideological spectrum. In most of them, they would assume voters have some utility function for which they're optimizing. The classic one is the Downsian model, which assumes that there are two parties and they sit somewhere in a one-dimensional ideological space, and the voters, their utility is ideological closeness. So they want to vote for the party closest to them, and everybody votes. The result of this model is that both parties want to converge to the position of the median voter. And that is obviously not what happens in politics. So something is missing from this picture. What we want to do here is, What we want to do here is we looked into the psychology literature and we find that maximizing is not often how people make decisions. In real world complex scenarios, people tend to do what's called satisficing. That is, they don't seek the best, they settle for something that seems good enough, and they don't obsess over other option, and then it typically applies to scenarios where you don't get complete information or you may not care as much, which seems to be a representative sort of a reflection of many voters, sort of what they go through when they decide who to vote for. So we want to come up with a mathematical model that incorporates satisficing into a simple framework and see whether that can explain some of the polarization patterns we see. Okay, this is how we set the mathematical framework up. So similar to the Downsian model, we assume a one-dimensional space, and there are two parties sitting on this space at position mu I and mu j, and there is a population distribution noted a rho of x on top of it. Here we assumed this population distribution to be Gaussian, which reflects some of the population survey data that finds most people are still moderate and middle of the road. And the satisficing behavior we describe as the following. So for each voter at a position x, if they're satisfied with one party, but not with the other party, they vote for the one they're satisfied with. If they're satisfied with neither party, they don't vote. And if they're satisfied with both parties, they vote for one of the two with equal probability. That they're both good enough, I stop caring. And how likely, oh my gosh, what happened? Okay, how likely are a voter to be satisfied with a party? And we assume that should be decaying with the distance to the party position. So if I'm perfectly aligned with where the party sits, I'm going to be always okay with that party. The further away I am, the less likely I'm going to be satisfied. And we describe that function with this red function S of x, which what we call the satisficing function. It's another Gaussian parameterized by the width sigma that we called the party inclusiveness parameter. So saying if I am a certain distance away from the party center, the more likely I am to be satisfied with it, it says the party has casted a wider net and tried to appeal to a broader audience. Okay, so with the two parties and their two satisficing functions, we can compute the proportion of voters at any position x to vote for party I, and that's sum of two parts. So the first part is those who are satisfied with I only, so those who satisfy with I but not with J. And the second part is half of those who are satisfied with both parties. Then we can compute the amount of votes a party is expected to receive. That is, we simply take the integral of this probability weighted by the population density function. And lastly, we assume parties want to win elections. They want to maximize the votes they receive. So the party position will change towards the direction that increases the votes they received. And that's the end of the model. The model is basically two ordinary differential equations. So there's one equation for party I and then a similar equation for party J. Any questions about the math here? Yeah, Luis. Yeah. Yeah. So here we assume sigma is the dynamics of sigma we don't know. So later on I'll show you, we kind of read it from the data. I think a future question is how does that dynamically evolve endogenously? Any other clarifying questions on what we saw here? Okay, moving on. So the model behavior is as following. So here we're looking at a diagram where the two axes are the position of party 1 and party 2, which is vertical. And here we're just putting in some symmetrical parameters between the two parties. So the model predicts that for most parameters, the two parties will stabilize at some finite separation from each other. So here the vector field would say this is where how the party want to move if they were starting from the base of the arrow. So this is already quite different from the Downsian model framework where two parties will want to converge. A sort of a better way to look at this model is to compare it with the data. So what we did is we started the two set of differential equations with the initial condition of the two parties back in 1861, the start of the data. So these two positions were from the data. And we evolved the two differential equations forward in time. And there is that parameter of party inclusiveness that we don't know. And we are making this assumption here that the party inclusiveness at a given time is proportional to the standard deviation of the congressional member. So the diversity among a party kind of represents how widely it may appeal. So the data exists for every congressional term, which is 2 years. So every 2 years, we take the input initial condition and the inclusiveness parameter, and the model outputs where the next, the party position would be in the next iteration, and then repeats over time. And there are, I think, a few constants that are estimated here as well, including a time scale constant and then the width of the population distribution. And so the model is in the dashed line, and the solid line was the data we saw before. So we can see that for most part of the model, there's some sort of resemblance of these two. However, there are also noticeable deviations. For example, in the 2 world wars over here, there's some noticeable departure from the prediction and the data. And also the model is not able to fully explain the Republican drift to the right that we see in the more recent period. So suggest something else might be happening sort of on top of what we've assumed that's sort of affecting the Republican Party in the recent years. Another way to look at this comparison is to look at the distance between the two parties as predicted by the model, which is vertical, and in the data is horizontal. So there is about a 0.75 correlation between the two. If we looked at the distance between the two parties as a function of the inclusiveness parameter that we said above, there is a decreasing relationship, meaning the parties that are less inclusive will lead to the two parties drifting further and further apart. The way that I've interpreted what this inclusiveness parameter means is some sort of ideological purity, that if being a Democrat or Republican means not only agreeing on stuff like tax rates and size of government, but also includes a bag of other things like your opinion on abortion and gun control and immigration policy. And as the list expands, this ideological purity shrinks. So that's what I think is reflects this horizontal axis parameter. So here we assume, so basically from this, we think the more ideological purity a party is sort of displaying can lead to more polarization of the parties. And note that in this model, the population distribution didn't change at all. So some of these party polarization dynamics could be explained by the games the parties themselves are playing, regardless of what the voter are doing. So that is one possibility. So party inclusiveness, which is the, we basically end up reading is proportional to the spread of a party in Congress. And then the distance between two parties is just this distance. Yeah, so the greens are data. Triangles are model, yeah. Yeah. Uh-huh. Okay. Okay. Yeah.
Prior to 64, right?
Yeah.
So that had, I think, a huge impact in kind of the spread, right? Because then at some point after civil rights, you had a lot of them turn Republican. Is there a way to handle that?
Yeah, so Luis, you're mentioning like the realignment era, is that right? So basically, what Luis is pointing at, it used to be the Republicans are the more socially liberal party, like Lincoln was a Republican who wanted to abolish slavery, and then something changed over time. So there was a shuffling of party labels at some time. So in this data, you can't really see the shift of two dimensions because of the relativeness of this. So I think it might be reflected in this within the 60s, the spread is much larger. So I think to get at your question sort of more seriously, one may need to sort of come up with other computational tools that can map positions on concrete policy issues. I think that is a great, I would love to have that, but I personally don't know how to achieve it. Maybe some of you know, and we can chat more. Okay. I'm gonna move on so that we finish the next thing and then we'll come take questions. Okay. All right, so to conclude what we saw here, so in this project, we developed a mathematical framework to include satisficing into a model. And we find party polarization actually does not require the voters to change, and parties targeting this narrower range of ideological space can be a sufficient explanation. So having done the first project, I was just in generally struck by the disconnect between the voters and then the elected people who are supposed to represent them. And that motivated me to sort of look at collective decision-making in general and ask what are some conditions in which we see it fail. And this led to this other project. The motivation of this is that there is good evidence that there's widespread political ignorance in the United States, meaning that there are surveys that go out and ask people, and they found many, and some argue most of US voters cannot tell you basic facts of how the government works and what are the platforms these candidates are actually proposing. So these uninformed voters, they might just go learn from their friends, their family, people online, and so on. And echo chambers might make this matter worse. So the central guiding question is, can we trust a collective decision-making process like democracy to give you good decisions? And we'll define what that means, given that some members follow others instead of evaluating the merit of options on their own. Okay, and there has been plenty of research trying to get at this question from the field of collective intelligence. That's to study the performance of human groups. The mainstream understanding is that social learning, aka following other people blindly, is bad and is popularized by the book Wisdom of Crowds, saying if you have people influence each other, people are just gonna herd into some direction regardless of whether direction is good or not. But there has been also other quality empirical studies that have shown the opposite, saying if you allow people to deliberate and discuss, each individual arrive at a better answer. And then when you aggregate them, your choice is actually better. And on top of that, when you have social learning, it's easier to come to a consensus. Say if a group of friends are deciding where to go to dinner, you would want a bunch of them to have no preferences so you can decide on something. Okay. So we think there are conflicting findings because collective decision-making is the outcome of complex interactions of many variables. But in especially empirical studies, a lot of these variables has to be studied in isolation with each other. So what we want to do here is to create a general mathematical framework that can analyze a lot of these things together and make predictions on how these different factors combine to generate certain kind of result. Okay, here is the way we mathematize this. So imagine there is a well-mixed population that anyone is equally likely to interact with anyone else. And there is a binary choice to be made between two things. It can be two candidates, green and blue. And the population is made up of two types of people. There are proportion S of social learners and proportion Y minus S of individual learners. And individual learners, they base their decision on what I call the relative merit of the options. That is to say, they evaluate things like facts. And so here I'm also assuming that people can have heterogeneous preferences, that after they evaluate the same factual information, they may arrive at different conclusions still. So for example, what color to paint this room in, if I gave you everything of color theory, different people may still arrive at different preferences. And then for social learners, their decision, I assume, is based on conformity. That is how often they see other people show the same type of belief and behavior. So in the psychology literature, there can be two types of conformity response. In both of them, the likelihood of adoption rises with the observed frequency in the world, but they can take either S-shaped or inverse S-shaped, depending on how this individual is motivated. So the S-shaped is usually motivated by people trying to fit in, and the inverse S-shape is usually motivated by sort of less social motivation, more like trying to find the best song to listen to on Spotify. Okay, here is the mathematical framework that for individual learners, they can either prefer option X or option Y. So there are two categories, and the proportion prefer option X is Xi, and the people can transition between these two states with some probability. Going from X to Y is P XY, and then vice versa. From this, we can write down a statement of conservation that says the rate of change of people in prefer option X is made up of two parts. The first part is people from the other camp coming in, and then minus people from my camp going out. So that's a statement of conservation of people. And then we can draw the same picture for social learners and come to the same equation. The only difference is this subscript and superscript I for individual learners is changed to S for social learners. Then the essence of the model is really figuring out what these transition probabilities are. So for individual learners, we consider their transition probability from Y to X is a constant M that's between 0 and 1, which we call the merit of the option X relative to Y. So that is for an average person, how likely they are to choose X after evaluating all available information to them. So 0.5 means neither is better than the other, is painting this room blue or green. 1 means X is always better than Y for any individual person, and 0 means the other way around. Okay. So by symmetry, this transition rate the other way around should just be 1 minus M. Okay. For social learners, the probability of transitioning should depend on this frequency-dependent conformity response, which we call the F of X, where X is a proportion favoring option X in the whole population, regardless of whether they evaluate facts or blindly follow other people. So it's a weighted sum of XS and XI. And this function F should be increasing, sort of mimicking the psychology literature that we see before, and it should be symmetrical around the midpoint. So we end up coming up with this piecewise form. Understanding this equation isn't important. The point here is we have one parameter alpha, varying which give you both the S-shape and inverse S-shape response that we see in the literature. So basically, S bigger than 1 give you the S-shape, and smaller than 1 give you the inverse S-shape, and 1 is the linear response. So it covers the whole spectrum of conformity behavior. And then by symmetry, the transition rate vice versa is just the same function, but with 1 minus X as the argument. Okay, putting it all together, the model is a system of 2 ordinary differential equations, and we figure out these 4 transition rates. We plug them in, and we can simplify the system quite a bit. And what we're ultimately interested in is the proportion favoring option X in the whole population and how that changes with these model parameters. So I'll show you, this is equilibrium results. So looking at the fixed points or the equilibriums of the system, that in the case of equal merits, that M is 0.5, neither is better than the other. And this is also in the case of S-shaped conformity, I should mention. We see that as when the proportion of social learners are low, the population arrives at a 50-50 split, which is as expected because neither candidate is better than the other, according to the facts. But then when the proportion of social learner is high, the group will end up herding to one candidate or the other overwhelmingly. So a natural question to ask is, what is better? Like, where do you want to be if you are sort of designing a group? And that depends on what you want to accomplish. Let's say if you want to elect people into parliament and you want the elected people to reflect the underlying population distribution as accurately as possible, then you may want to be on the middle branch. However, if you're trying to decide, say, which side of the road to drive on or where to go to dinner, it may be more important for everybody to agree on something than to optimize for representativeness. Okay, so what's good, it kind of depends on what you're trying to achieve here. Okay. On the right-hand side is an example where option X has slightly higher merit than option Y. So here is 0.6, it's starting 60% of individual learners want option X to happen. What happens here is when we have a low social learners below this critical threshold, if I took a majority vote, I'm guaranteed to choose the high merit option. But if the social learner is high, I'm no longer guaranteed the high merit option. I can end up choosing the other one. And that depends on fluctuation and the initial conditions. So if we define what is good in the election is to choose the majority preference among the people who actually thought about this thing, then the high social learner case can lead to a bad outcome in some scenarios. A natural question to ask is, where are these critical transitions? And we could solve for that in the model. And that depends on two things. One is the merit of the option M. So the closer to a 50-50 split the underlying options are, you lower the threshold for that critical transition. And the other thing it depends on is the shape of that conformity function here. So the more nonlinear and S-shaped it is, the lower that critical threshold is. Okay, another prediction from the model is that there can be some history dependency if the underlying merit changes over time. So for example, during the pandemic, in the beginning, there wasn't enough information to suggest mask wearing is helpful, but then things changed later on and people found out mask wearing is really helpful. So basically, if the merit changes over time and slow enough for the system to equilibrate, in the case of low social learning, we predict a smooth transition that a crowd will more or less adjust accordingly. But when high social learning is happening, we predict that as the mask wearing merit increases, we'll first be stuck on this lower branch, so the population isn't doing the right thing, and then it will suddenly jump up, and then the transition will be quite fast. Okay, it's mask wearing. So in the model I showed you here, we made several extremely simple assumptions. So in the paper, we try to expand on this baseline model. I think the simple model helps us build intuition on what's happening and generate some understanding. We also tried to extend the hypothesis made here to reflect more realistic scenarios. So the one I'll highlight here is we made this extension in which that relaxed assumption of a dichotomy between social and individual learners to a spectrum of social and individual learning. So everybody can be on a spectrum of learning fully socially or fully individually by evaluating the facts. And then we write an agent-based simulation in which the transition probability depends on two things. So it's a weighted sum of the merit and the conformity function. And each person has a number S between 0 and 1. So 0 means all individual learning and 1 means all social learning. So here are some results from that. So on the left column, we're drawing a distribution of S from a uniform distribution. And we see that as the merit changes from low to high, we see a smooth transition, similar to the low social learning case we saw in the simple ODE model. On the right, we're drawing this parameter S from a skewed distribution to the right, suggesting there are more, people tend to do more social learning. And then we see this bistable state appearing here as well. So this suggests basically what happens here is similar to the high social learning scenario in that simple ODE model. So it's a way to how about check the robustness. Yeah. Yeah. What do you mean meta stability? Yeah. We haven't done the multi-choice yet. So here it's just between two things. So we thought about extending it to say like a finite n, say like 3, 4, 5. So one can in theory formulate this model. It gets messy because you need to know the relative merit between every pair of things. So I think understanding what's sort of a real, sort of a helpful way to untangle that is where we hang up on. But I think it's doable once to extend it to multiple choices. Yeah. So you may end up with a rock, paper, scissors situation. So like there could be loops happening and then a lot of weird stuff happen once you have that. Yeah. Okay. Okay. So the results I showed you here are all for this S-shaped conformity function. So I know it may be a little confusing, but the reason we sort of brought up this distinction is when you have the inverse S-shaped function as the conformity function, a lot of these weird bistable behavior goes away. So that's suggesting even if you have high social learning, if you're able to make social learners react to let me show you here. Yeah. So if you're basically in this orange function, a lot of these transitions are quite smooth. So if you're worried about this bistable scenario, one intervention is you can help the social learners sort of react a little differently. So the difference between these two shapes is in the S-shaped, being in the majority matters a lot more, while in the other one, it matters a lot less. So the transition is a lot smoother. Okay. Okay, so I'll summarize the contribution in this model here. It basically characterizes collective decision-making into 3 parameters. One of which is, so there is the social proportion of social learner, merit of option, and also the conformity response. And then the combination of these parameters can distinguish a broader range of behavior. And I'm hoping a structure like this can help people sort of summarize what you would expect in collective decisions given some combination of parameters. And this model is also simple enough to be analytically tractable. So in the paper, we actually have some analytical results that predict where these transition points are and so on. Lastly, it's flexible enough to incorporate, to be able to expand it, to include a lot of other kind of mechanisms, because the backbone of the model is a sort of 2-stock and by-flow structure. So people going from one bucket to another bucket. And basically, by changing what those flows are between the 2 buckets, including different mechanisms, you can expand the model to consider a lot of other things. So in the paper, we did an extension where we also included committed minorities into this framework. So I think there is a lot of room to sort of unify a lot of these different opinion dynamics considerations. Okay, so that's all the science I'll tell you. I know that we started this talk with some of my skepticism and cynicism of how often collective decisions could fail us. And I would like to end this talk with a quote by James Baldwin, who is a writer and activist who lived through the civil rights era as a Black gay man. So he has seen all the failures and violences that come out of the group dynamics, but he gave us a word of optimism, which is this. He said, we've got to be as clear-headed about human beings as possible because we're still each other's only hope. So with that, I thank you for your attention. I'll take any questions.
Hi. Can you give us examples of what you mean by merit? Because I think I maybe missed that in your talk, but what I don't get is how you can ever define merit, and maybe like a couple examples of the real world maybe could help elucidate that. But the way I see it is that merit is a value judgment. Yeah. And so if 2 people have different value judgments, they're just, even if it's like a 50% chance of $100 or for sure 50, I could say those have equal merit, but you could say, well, I have risk preferences. And so just trying to get at like how you can ever get.
Great. So here, the merit here is not a property of an individual, but instead it's like a group level description. So in your example of equal chance of 0 and 100 versus short chance of 50, each individual may arrive at what is better for them. in that scenario, which is fine. The merit on the group level is saying, okay, among these people, maybe 70% preferred one thing and 30% prefer the other thing, then the merit 0.7. Like that's the description. So it's not making like a normative or moral judgment on anything, but it's just saying among the people who thought about this carefully, what do they arrive at and what's the distribution there is. So in the model, there is the social learner sort of by definition is acting on information that's purely social, basically their observation of what others do, while it's kind of assuming everybody else who don't look to others to behave, like sort of we're kind of assuming they will read, say, something about climate science or reasonable news articles to arrive at their decisions. Yeah, that's the assumption there. But some of this can also be debated, given like some of the news people read are not actually real and so on. Yeah. Okay. Other questions? No.
Okay, so again, it might lead to a lengthy conversation, or I might just be asking a very stupid question. I want to put you into a little bit of trouble based on what you said, because you motivated the second study based on the first one. So I'm trying to figure out how to wrap my head around how to plug in and going back to the merit question. So in the first study, you have these two, you have a position, you have a space, right? There's no inherent merit on it. I'm trying to figure out how you would plug in the understanding from the second chapter, second study into the first one. So you can think about it in terms of the parties changing their position relative to the merit that arises from the distribution of the population preferences. So that's one way of thinking about it, right? The other way is how people change their distribution or voting preferences in response to some merit that could be quantified potentially based on their distance. So you see that,
I see. So I think the subtle sort of maybe differences between the two model approach is the first model assumes everyone has some preference, like everyone has a place in sort of liberal to conservative policy space where they sit, which is pretty common in political science. The second one is to say, actually, some people, they may not really have sort of preferences in the way we've thought about it. Maybe they're just following other people, and then we're sort of interpreting their preferences the same way, and so on. So there could be inherent changes in people's preferences. So among the people, I guess, learn individually in the language of the second model. So that would represent like shift in the population distribution over time and so on. So that's also a possibility.
So my question is a sort of a follow-up question of the Mo's question. So in the first study, you have like a preference of each of the person, and you consider that is to be certain and it's not changed. The second one, you assume that some of them don't have a preference. My question is, there's some situation, actually there are some situations that your preference will be changed based on the circumstances and your peers. So that brings in some of the evolutionary game theory models. So my question is, how do you want to incorporate these kind of methodologies in your study? And have you considered these kind of models, like social learnings and evolutionary game theories, and how to apply these to political science researchers?
Oh, okay. So, okay, that's a big question. The first question is about when the sort of the preferences change or situation change, right? There's actually a current project where we're doing that, where like something like the merit changes slow at some rate, and then like there may be some contagion process in which people become aware of, say, climate is changing and so on. So there are folks who so you first need to be aware, and second, you need to be persuaded that you actually believe this thing. So I think, so there's a separate ongoing work that explores this, maybe in the framework that's similar to the second model I showed you. With the evolution game theory, I'm not an expert in this field. I've like read a few things. I think it's a reasonable way to approach some of these group dynamic question. I don't have like I don't have a good thing to say on what's the connection there for me yet, but I think it's a totally reasonable thing to consider as well.
A question
Yeah.
related to the first part, and it's actually about the role of primaries in the US system, because in a sense, they also play a role, because when you look at what people can vote and how they vote, is that something that you have looked at or not yet? And how?
Yeah, primaries, I haven't looked at it yet, but a lot of people in the political science space has. So they've there's a lot of blame on primaries, suggesting because the folks who vote in primaries tend to be more extreme than the people who vote in the general election. So the primaries tend to pick out the more extremist candidate, which get pit against each other. So there has been a lot of blame on that already from the political science community. It's not within the framework of this model, but there's also, I forgot when did US primaries start to happen. It's not always we don't always have a primary, I think, for presidential as well. So there may be some interesting, like when did that happen, compare time and that kind of thing.
And if they are open or not.
Yeah.
Because in some cases you cannot, but that would be kind of interesting.
Yeah, definitely.
With regard to the second part, one way in which some years ago we studied agent-based modeling of something like that, of consensus, and one way in which we thought about it was as a model for how science works. So the ones that studied the issue are the ones that use individual information.
Yeah.
And one way to model then what the merit would be in that case was in the sense that if you use an experiment to try to find is a theory true or not, and you have no perfect experiment, there is a chance that you are going to get the right answer and or the wrong answer, right? And that naturally already gives you the M, right? Which is, and it could change because over time maybe you have better experimental methods or something like that. But what is interesting in that case is that in almost any scientific context, there are a few people that actually study a topic, and most of us are followers.
Yes.
Right? We say those few people that study climate change know their business. Right? We look at how many of them are saying that, and I'm not going to repeat their calculations. So I think that's a context in which this kind of thing is very important.
Yes.
Right. And it solves some kind of the issue of merit is, right? Because it could be think about an honest agent that is trying to find an answer with an imperfect method, right? And what's the probability that they will get a particular answer?
Yeah, that's a really good example. Thank you. I haven't thought about the experiment thing, but that's great to know. Yes. Okay.
There is never one experiment that solves the problem, right? It's sort of evidence kind of builds up, and we sort of form the consensus. And many times it's not only the experts, but other people are also kind of saying.
Yeah. Thank you.
Question on sort of on the other aspect of this, not on the evidence building up for what individual actors would choose, but for the social learners, especially with opinion, maybe more so than with science, but even in science, they have some imperfect method in reality of assessing what fraction of the population chooses A versus B. So especially relevant to echo chambers online, right? So if you thought about that with that feedback, you could imagine it could even become multi-stable, more multi-stable, or there could be other dynamics.
I've thought about this like in an experimental setting, sort of Like you can give participants a script that, well, it may not have, it probably has to be about something that's not already political yet, but a script about some evidence for one thing and some evidence for some other thing, and then have them evaluate and so on. So I think that's the context in which I was thinking about it. In the real world, there may also be some mappings of that. It's kind of confounded because in the real world, learning from facts and also social influence process is confounded in what we see. So that gets a little messy. I love to have scenarios where that can be teased apart. Anybody else?
If there aren't other questions, we can thank Vicky again for
Thank you.
a very interesting seminar. Thanks, Vicky.
Just a programming note before everyone leaves. Next week, we are in the Kellogg Global Hub. So different location. Same day, same time, just at Kellogg.